Lesson 37, 7.5, difference of two squares, factoring completely. Basically, we're given the form a squared minus b squared. Big hint here is that a value, that first value, is positive, so we want that value to be positive. This is, when rewritten, is actually essentially a plus b, a minus b. So they're equivalent. If you were to FOIL this half here, you'd wind up with what we have over here. Another way to write a plus b and a minus b is you can simply write it in that fashion as well, a minus b, a plus b. Both are saying the same thing. Really what has to happen in this problem, if you look in example A, you have 16v squared minus 9b squared. What you need to envision is basically taking this binomial and almost taking the square root of the entire thing. So when you square root it, the square root of 16, when you get that square root of 16, it'll give you 4. The square root of v squared is v, so you've taken that down. In order to get back to that 16v squared, really what happens is you square the 4v. So 4v times 4v, well, 4 times 4 is 16. V times v would give us the v squared. Drop down the minus sign. Envision square rooting 9b squared. Well, square root of 9 is 3. The square root of b squared is b. Now to get back to the 9b squared, we'd square that. So really what you're getting here is this normal equation right up here, the a squared minus b. Well, this is your a squared minus your b squared. Okay, those squares are right there. So your a value really is 4v, and your b value is really 3b. So now you can apply this equation that we have up here. Substitute in for a, substitute in for b, a, b. So we would wind up with 4v plus 3b and 4v minus 3b. And you could always double check. You could FOIL this. When you FOIL it, you'd wind up with what you started with in the 16v squared minus 9b squared. Example B is a little unique. The reason why this example is unique is prior to even starting anything, if you look at the binomial, you can factor something out. So you always want to deal with the smallest terms as possible. So we want to go ahead and factor this. In both terms, notice we have 27 and we have 3. I can factor something numerically out of this. I could also factor something like a variable out of both terms. I can factor a 3 out of 27 and 3, and I can factor an h out of h cubed and h. So basically we need to factor out a 3h. When you factor out your 3h, you have 3h, and in parentheses you have 9h squared minus 1. Now this is the part where we need to envision basically square rooting that. If you look above here, square rooting this, you're not going to be able to figure out the square root of 27. It's not going to give you that integer that we're looking for. So now we can go ahead and square root this, and I'm going to keep 3h on the outside. Well, envision square root of 9. The square root of 9 would be 3. The square root of h squared is h. To get it back to the original form, we would square it. And then we would say minus, well, what is the square root of 1? The square root of 1 is 1. How do you get 1 back to 1? Well, you'd square it, right? So now you have your a value and your b value. Here's your a squared minus your b squared. So your a value would be 3h, your b value being 1. So down below we're going to go ahead and put it in the form a plus b, a minus b. So we have 3h, and in parentheses we have 3h plus 1 and 3h minus 1. Skills check. I want you to go ahead and give example C a shot here. So I want you to pause the video, and then after you do C, we'll check back in, and I want to help you out with D to start, because that is a little bit different. So go ahead, pause the video here and work through example C. Hint, some of these you might need to factor something out first. Now that you're back here in the first set, we should have go ahead and factor out an x out of each of these terms. When you factor an x out of each term, you're left with 9x squared minus 4. Again, remembering that this is basically almost thinking like you're taking the square root from that problem. When we do that, the next step that we have x on the outside still being multiplied to everything on the inside, and we have 3x squared minus 2 squared. This being our a value, this being our b value, and then we can go ahead and wind up with x on the outside, and we have parentheses 3x plus 2 and 3x minus 2. The reason why I wanted you to hold up with example D here is notice when we normally do this problem here, we have a squared minus b squared, right? Well, this first problem here is actually a negative a squared, and this right here is really saying plus b squared. Two things that you could do. One thing you could do is rearrange these numbers so you would have a 9x minus 4x cubed. Then you'd have your positive a value and your negative b value. Or you could simply factor something out right away. And I know I can take an x out of both terms, but I could also factor out a negative 1. So I could factor out a negative x. When I factor out the negative x, this is no longer negative 4x cubed. It is 4x squared. It is no longer 9x. It is negative 9. And again, a way to double check that is go ahead and distribute your negative x back in, and you would find out that you'd be left with the same what you started with there in D. Next step is go ahead and envision your square root here. And maybe you could pause the video right now and continue on. Now that you're back here, you check it out. We have the negative x on the outside. We have 2x squared minus 3 squared. We rewrite this in that form a plus b, a minus b, and we wind up with negative x parenthesis 2x plus 3 and parenthesis 2x minus 3. Example E. This is very similar to kind of what we talked about down here. You could actually write it, if a lot of people like this, with their variable first written in standard form. You'd notice that you actually, in this problem, you'd need to factor out a negative 1. Or you could go ahead and take it as is, the 121 minus 4b squared, and this would be considered your a value, and this would be considered your b value. So this is kind of what I attacked it. We attacked it like this in example E here. So I envision the square root here, and I have that square root. Well, I would have 11 square it minus 2b square it, and then I go ahead and I wrote out that pattern there, 11 plus 2b and 11 minus 2b. These challenge problems here, I'm going to work through one and I'm going to have you tackle the other. The first problem that we have here is, well, we need to go ahead and envision the square root again, and if we square root 625, we'd end up with 25 squared minus x squared, and this would be squared because we have that power to a power, right? The power to a power, 2 times 2 is going to give us x to the 4th power. So this is what you would have, and then you would go ahead and rewrite this. Well, we have 25 plus x squared, and we'd have 25 minus x squared. Now, the reason why we have this as a challenge problem is because when you have the form a squared minus b squared here, right? A squared minus b squared. We're able to square root these and come up with a new portion, a plus b, a minus b. If you look at this, The 25 plus x squared, well, that is going to stay the same. The reason why is because of the plus sign. Well, when you have a squared minus b squared, right, you can take the square root of that. If you actually look at this example, this can get broke down again. So you're going to have 25 plus the x squared. Now envision your square root going into this problem right here. Okay? You can actually get out of it, and I'll just kind of group this here, but the square root of 25 is 5. Square it, it's back to the original, minus, there's that equation, right, that we're working with. So this is why we can do the square root again, because we have a negative. Well, we can figure out the square root of x squared. That's really going to give us x. Square it. So now we rewrite this as it would be for a squared minus the b squared. So your actual answer here would be 25 plus x squared. When you take this form here, you would actually wind up with 5 plus x and 5 minus x. This would be our answer here. Now, a lot of people are like, oh, God, I have that negative sign here again. Well, we can't break this down. A squared minus b squared. If you took the square root of that, we couldn't figure out the square root of 5 and the square root of x. That's why you can't take it to the next level there. But you can here. So that's why it's a challenge question, because you actually have to apply the technique more than one time. And that's what you'll need to do in example B here for the challenge problem. So go ahead and pause the video and work through it. When I take the square root of the first step, this is what I should wind up with. And you can just kind of, this would give me a to the 4th. 2 squared would give me the 4. B squared, well, power to power multiply, so that's giving me b to the 4th. So you'd write things out, and you would have 2a squared minus b squared, and 2a squared plus b squared. Now, I threw this at you to see if you could catch this. You actually cannot apply the technique more than once. Reason why is here's really the a squared minus b squared that we apply that square root to. If I applied the square root to this, I can't figure out the square root of 2. Okay, I can figure it out if it were the square root of 4, that would give me 2, but I can't figure out the square root of 2. It's not going to give me that whole number, that integer. So this here in this example actually is our answer. This will conclude lesson 37, difference of two squares.